So that is one set where you will be simultaneously determining metals. Another set of practical, again consisting of three practicals, that is analysis of fats and oils. जैसे कि if you are an analyst and you are given an unknown uh, oil sample या any kind of fat sample, ghee or these kind of things, then there are certain parameters to analyze them. What kind of oil it is, um, in which category it belongs, is it edible, can we take it, certain oils we use in kitchen, certain oils we use for hair, certain other oils we use like in industries, lubricating oil. There are different uh, categories of oil. So those kind of things we will see in that. Certain parameters to understand oil. This is the second set. And there is a third set which consists of separation techniques. That is, we will be talking about TLC, thin layer chromatography. Chromatography, as you all know, is separation technique. So in that, we will be separating out mixture of two things. Say you are having a mixture of drugs, then how will you separate those drugs? Or if you are having a mixture of in your practical, in your syllabus, you have mixture of dyes. Two dyes are mixed together, then how will you separate them using thin layer chromatography? So that is the third set of practicals we have. And the fourth set of practicals, that is not entirely same. Out of the three practicals that are remaining, two are water analysis related. In your SEM 1 also you had performed water analysis. If you remember, there was this practical of TDS, determining the total dissolved solids. Similarly, hardness of water. Those were some of the parameters in water analysis. So similarly, in this SEM, you will be advancing a little more. You have a practical of determining dissolved oxygen. We call it DO, dissolved oxygen in water. That is again a water parameter analysis. You have one more practical called COD, chemical oxygen demand. This is again a water parameter. You are given water sample and you have to find out what is the COD level of that water. Now, so far I talked about 11 practicals. The last one being, again it is very practical oriented. It is, you have to determine the amount of iron in iron tablets. So these are the practicals we will be focusing on in this semester. And today we will be beginning with the first set that I talked about, the complexometric titration. Now, as I said, here we will be simultaneously determining two metals present in a mixture using EDTA. It's very simple. We have already seen it. These type of this particular kind of titration in your previous SEM. Similar pattern, but the metals are changing now, and we will see what is the difference. Everything doesn't happen the same way. You cannot detect all the metals in similar fashion. We need to change certain parameters based on the metal that we are detecting. So that we will be seeing in this particular lecture. Before I continue, complexometric is one type of titration. So can anyone tell me which are the basic 4 types of titration? At this stage, you must be able to say. 4 basic types of titrations are there. Which are they?
Ma'am?
Yes, Richa?
Ma'am, acid-base titration, redox, precipitation, and complexometric.
Fine. Good. So these are the 4 basic ones. And last semester you saw examples of each one of them. Each of them were covered in last semester. So here we again continue with the complexometric. Now what is so special about EDTA titration and why is it exclusively used for metals? EDTA complex, you know how it looks, the structure you know. It is a hexadentate ligand and it is capable of specifically binding with metals at it can bind with metals if you give it certain environment. You need to give it certain favorable situations where it can come and bind with the metal. Now what are these favorable situations? It is the pH of the system. This favorable environment I'm talking about is pH. You play with the pH, you change the pH, you can capture different metals from a system. So the first practical we will be discussing is determination of calcium and zinc using EDTA titration. There are three titrations like I told you. The first one is determination of calcium and zinc. The second one is determination of mixture having magnesium and lead, magnesium and lead. And the third one is a mixture containing iron and chromium. These are the three mixtures that we will be discussing. Now, out of these three, zinc, calcium, and lead, magnesium, they run parallel. Means everything about them is same. The entire practical process in these two remain the same. They follow the same protocol. So the only difference is we are changing the metals, but keeping all the environment same. You get the you just have to follow the same procedure. Now, what is this procedure? I will first talk about calcium zinc. Try to keep up with me, and since we are talking on this platform, try to keep up with me. I'll tell the possible color changes, when, what happens, how it happens, and at the end you will be, I mean, after this you will be shown the video also, so that you get a better understanding of how this is being done and how you record the color change, how you find out the endpoint. So it is like this. Your aim, for the first practical, the aim is like this. You are having a mixture of metals. The metals constitute of zinc and calcium. Now you have to find out from that mixture how much of zinc is present, how much of calcium is present using EDTA. First of all, what you'll have to do, you will have to prepare all the solutions. You will prepare a solution of EDTA. You will prepare a mixture of zinc and calcium, which students don't prepare generally. It is given to you. We prepare it because you have to find out how much is present, right? So we calculate certain amount and prepare that unknown solution, and everyone is given that unknown solution in a small beaker. That is your sample of analysis, and that beaker contains certain specific amount of zinc, certain specific amount of calcium. Your aim is to find out how much. So that solution is prepared, and then you have the important part, indicator, which we all need. Now, in these kind of titrations where we are working with metals, the indicators used are commonly called metallochromic indicators. They are used very specifically for whenever metals are present. Metallochromic indicators. You all know that when you were doing acid-base titration, there were some specific kind of indicators that you used. Those indicators worked well under certain pH. Acid and base have, matlab it is working with pH. So you needed indicators that would function well at that specific pH. Now here, since metals are there, we use different kind of indicators which bind well with the metals, and they are called metallochromic indicators. And for this practical, we need the indicator EBT, which is called ideochrome black tea, and the second one is silanol orange. These two indicators will be primarily required. So that becomes our main solution, and indicators are also ready. And now, if you recall, the main step, in order to bind with the metal, EDTA requires a specific environment, right? And what is that environment? We have to change the pH. In order to change the pH, we will use certain pH changing medium, such as for this practical, we will be using a buffer, that is pH 10 buffer we will be using. Secondly, we will be using one more chemical compound called hexamine that again helps in maintaining pH, hexamine. So these are the things we will be requiring. Okay. Now what happens? I need you to understand uh, this thing. The procedure is somewhat like this. You are having your mixture, right? You are having your unknown sample. Now you have to start with the practical. You have to follow certain protocol and find out what it is. So your mixture you are having, you take it in a conical flask. Your mixture, take about 10 ml of your mixture. Now see, when I'm explaining the procedure, I'm not going exactly this much ml you have to take, this much ml you have to take. I'm not going exactly like that. Everything is given in the journal, which will be shared with you. I am highlighting the main point, that is what is happening once you add something. What bond is being formed, what bond is being broken. These kind of things I'll be paying more attention. So the ml and all you will be able to find it. Okay. So you take 10 ml of your unknown sample, metal mixture. You take that, and in it you add about 10 ml of water, distilled water. Now, in this you will add, now we are going to prepare the environment for the titration. So what you will do, in the first case, you will put pH 10 buffer. Add 10 ml, about 10 ml of buffer. So now your sample, the conical flask, is having a pH of 10. This is done. Now comes the role of indicator. You need to add the indicator. Okay, let me tell you, when you prepare EBT indicator, ideochrome black tea, when you prepare the solution, indicator solution you prepare, and then आप कैसे डालते, जनरली जैसे फिनोल्फिलिन सब 2-3 ड्रॉप्स डालते थे, वैसे ही इंडिकेटर सोल्यूशन EBT भी आपको प्रिपेयर करना है. उसमें से 2-3 या 4 ड्रॉप जैसे ऑप्टिमाइज करते हैं उस हिसाब से आपको ड्रॉप्स डालने हैं. जब आप इंडिकेटर प्रिपेयर करते हो EBT, its actual color is blue, dark blue, very dark shade of blue color. That is the original color of EBT indicator. Okay. Now, when this dark blue solution you add in your mixture यानी आपका जो मेटल है उसमें आप जैसे ही ऐड करोगे 2-3 या 4 ड्रॉप जितना भी रिकमेंडेड है, you will see that your solution जो अब तक कलरलेस था वो सडनली हो जाएगा पिंक कलर. It will be kind of wine red sort of color, dark pinkish red जैसा कलर हो जाएगा जैसे ही आप इंडिकेटर ऐड करते हो. So far, so much is done. You haven't begun with the titration yet. Titration has not been started. You have just created the environment needed for titration. So this is done. So you are having now a solution that is somewhat dark red, pink in color. Now you are ready for titration. So you take this conical flask, your burette stand. Burette is filled with EDTA solution, your complexing agent. Okay. Take your conical flask, start your titration. Now, when you start with the titration, in this particular case, now whatever I am talking for zinc, calcium, everything will be same in Magnesium and lead, the second practical, everything is going to be same. Even the color change is going to be same. So at one hand, on one point itself, your two practicals are being done. So listen carefully. Now, your solution is dark pinkish red. You will see that when we show you the video, it will be more clear to you. So once you start with the titration, now initially there won't be any color change because titration is going on. You see the color change towards the end point, right? So the titration is being carried on. Slowly you will see the red color shifting. The actual end point color in this practical is blue. That blue will be somewhat like, uh, you all know, a peacock's neck, the color of peacock's neck, right? Very dark, beautiful blue. That kind of color you will get. A little light version of that, but that shade you will get. That is the endpoint color. I'm describing the colors so that you can imagine what kind of blue it is. So that is the end color. Now what happens when you go along with the titration, slowly this pink original color we were having, dark pinkish red, wine red color, that will slowly start shifting towards blue. There is a tricky point in between, that is towards the end of titration. You will get a shade if you have done all the work properly. If you have done the entire procedure so far properly, then only you will find this part. Otherwise, generally, if students are careless, they don't see the intermediate color, they directly end up with the endpoint, which might have error. So every single step has to be done carefully. So what happens is that you know that pinkish red is on one side, blue is on another side. If you are good with colors, you might be knowing that uh, somewhere in the middle of these two colors comes the shade of violet purple. आपको पता है अगर हम red and blue mix करें तो purple violet color we can get, right? So at one stage, just before the end point, you will get a purple violet kind of shade of color you will find. If you find that, you are going on right track. And when you find this purplish violet color, the end point is very very near. एक बार आपको वो जो violet purple जैसा color दिख जाए, दो तीन drops में you will get blue color. That small window is there between these two shades. So once you get that blue color, it means the titration is done. The endpoint is, you have got your endpoint, and the first phase, first part of the titration is the mix. The main thing is, at this point, whatever I explained right now, whatever reading you get, that is for both the metals, calcium as well as zinc. Whatever reading you get, it means EDTA is bound with both the metals present in your uh, unknown solution. It is bound with zinc also, and it is bound with calcium also. अब इससे तो कुछ होगा नहीं ना. We need to find how much calcium is present, how much zinc is present. We need it separate, right? So for that, we will go on to the next phase. What is the next phase? In the next phase, we have a procedure which is exclusively to find out the zinc present in your unknown sample, exclusively for zinc. So what is that procedure? You again take the mixture, आपको जो mixture दिया गया है, you again take it, 10 ml you take the mixture, 10 ml पानी डाल दो. Now the main thing is, previously आपने क्या कैसा environment दिया था? 10 pH was the environment. Now if you need something different, you need to change that environment, right? So in this case, what you do is we take the second chemical compound that I talked to you earlier, hexamine. We use hexamine. We just there is no specific amount of hexamine. Our aim is we want to give prepare an environment of roughly 6 pH. अब हमें 6 pH चाहिए, so we will add hexamine which will help us in maintaining 6 pH. अभी आप कैसे फाइंड करोगे कि 6 pH है या नहीं? इसके लिए if you recall during your last STEM practicals we told you about pH strips. pH strip पता है आपको?
Yes, ma'am.
Yes, ma'am.
You know pH strips. They are very thin strips available in sort of orange color. We can roughly know. Yeah, I taught you pH meter, and during that I showed you the pH strips. Yeah, I recall now. So those peach colored strips are available. So for each pH unit of one, 2, 3, 4, like that, we can come to we can estimate the pH of the solution. So pH strips are available. So what we generally do in practical is आप थोड़ा सा हेक्सामाइन लेंगे, पहले उसको ऐड करेंगे, यू विल शेक योर फ्लास्क वेल, एक छोटा सा पीस पीएच स्ट्रिप निकाल के आप कोनिकल फ्लास्क में डाल देंगे. द ओरिजिनल कलर ऑफ पीएच स्ट्रिप इज पीच ऑरेंज, लाइट ऑरेंज कलर ऐसा है, एंड 6 pH पे द पीएच स्ट्रिप गिव्स द सेम कलर, सेम ऑरेंजिश कलर. तो आप जैसे ही डालोगे you can determine the pH range of your solution. अब ऐसा होता है कि अगर if you add just a little bit of hexamine, the pH is usually maintained. That is how all the chemicals are being prepared. So there isn't much issue in that. But sometimes it so happens that when we say a pinch means a little bit, you take it in a spoon, a spatula is given, a spoon kind of thing. So for every student, a pinch is different. Some just, for some people, the pinch is a little too much. For some people, a pinch is a little too less. Like that, it happens. In case, mostly it is seen when students add even a little of extra of hexamine. अगर ज़्यादा hexamine उसमें चला जाता है, then your pH strip will show green color. And if that is the case, don't go forward with the practical. You won't get proper results. Maintaining that average range of 6 pH is very important. अब इतना सेट हो गया, ठीक है? You maintain 6 pH. You are checking at the pH strip. Everything is fine. Now you go ahead and put the indicator. In this case that I'm talking about, the best indicator we have is xylenol orange. जैसे ही आप xylenol orange add करोगे, your sample, your unknown sample, which was until now colorless, it will become red in color. Red color solution बन जाएगा, एकदम bright red sort of. Now you are ready for titration. You will take this conical flask and start the titration with EDTA. So now again there is a little, it depends on how you perform the entire process up till now, what I said. The color change that we expect is this red color. Once the titration is over, it will become yellow. We get bright yellow color if everything went fine. But if you did something somewhere, if you were a little careless, or if any other contaminant, if you haven't washed your glassware well, or if there is any kind of contamination or unnecessary step, this bright yellow color you won't get. Instead, there will be a double shade between orange and yellow. You won't be able to say if it is orange or if it is yellow, and somewhere even you will find red shades also. This actually happens with students, and they come to us and bring the flask. मैम येलो आया, मैम ऑरेंज आया, मैम रेड दिख रहा है. अब आपने परफॉर्म किया है, आपको पता है आपने क्या क्या डाला. So the thing is, you have to be very careful about each of the small steps that you have performed. If you have done everything fine, you will get distinct yellow color. Double shade, triple shade, agar if you find, then it's very difficult to find the endpoint, and that will give you wrong result at the end. This is how the practical is being performed. This is the entire practical. Now, one more important step that I have to tell you is what is with the color change. What is happening and why this color change. So let me again go back to step 1. So this one that I explained right now for the color change of red to yellow, जब आप ये practical perform करते हो, that is exclusively for zinc. Whatever reading you get when you have this color change of when you put hexamine, and the second step that I said, whatever reading you get, that reading tells you the amount of zinc present in your sample. Only zinc, exclusively zinc. We will look at the calculations also how that is being done. But yeah, let me tell you about the color change. Going back to step 1, जहाँ पे we used the pH 10 buffer. मैंने आपको बताया कि आप सैंपल लेते हो, आपने pH 10 बफर डाला, EBT इंडिकेटर डाला. अब इसमें क्या होता है? I told you EBT indicator is originally dark blue in color, and जैसे ही आपका जो unknown sample है उसमें जैसे ही डालते हो it becomes wine red. Why is that? This is a metallochromic indicator. आपने जैसे ही इंडिकेटर आपके सॉल्यूशन में डाला which is containing metals, the EBT will bind with the metal. Complex बना, EBT इंडिकेटर metal complex बना. This is the initial case. आपने अभी तक titration start नहीं किया. So your EBT bound with your metal, and this binding gives you, when this indicator binds with the metal, it gives you that red color. अब आपका जो EDTA solution है, main complexing reagent जो आप इस practical में use कर रहे हैं, EDTA solution colorless है. It has no color, EDTA, and throughout the entire practical, EDTA remains colorless only. So this is the reason why we use metallochromic indicator. अगर आपका जो unknown sample वो भी colorless है, जो burette में है वो भी colorless है, everything is colorless, you perform the titration, पता है कैसे चलेगा कि कुछ हुआ, bind हुआ भी या नहीं, और हुआ तो कब खत्म हुआ, ये सब नहीं पता चलेगा ना. That is why we use the metallochromic indicator. So when your metallochromic indicator EBT binds with your metal, it forms red color. अब when it binds, a new bond is formed, right? There is some formation constant, certain value of that bond formed. It is not a very strong bond. आपका जो indicator and metal bond है वो ज़्यादा strong नहीं है, but there is a bond. अब जैसे ही आप titration start करोगे, that EDTA, burette में से जो EDTA that will get into your conical flask, it is a very strong complexing agent. So what it will do, it will break the bond between indicator and metal, and now this EDTA will go and bind with your metal. You're getting my point? EDTA will break the metal indicator bond because its formation constant value is high. It is a very good complexing agent. So it will break that bond, get in between, and EDTA will now bind itself with the metal. अब क्या हो रहा है? मेटल इंडिकेटर जो ऑलरेडी था वो ब्रेक होता जा रहा है. This means the indicator is now, which is getting broken from the metal, it is coming into its free form. The indicator is getting free. It is coming back to its original state in the free form. And that is why मैंने आपको बताया कि indicator's color is blue. So when it comes back to its free form, it comes to its original color, which is blue. So the entire color change we see is because of the indicator that helps us to know where the endpoint has come. This is what is happening. In the second case also the same thing, where we are using xylenol orange indicator. उसमें भी जैसे ही आप xylitol ऑरेंज इंडिकेटर ऐड करते हो 6 pH पे, xylitol orange will go and bind with the, now it will bind exclusively with zinc only, because that environment is favorable for zinc. Each metal has got its own pH value, where EDTA can exclusively bind with that metal. So 6 pH पे it is good for zinc. So जैसे ही आप इंडिकेटर xylitol orange डालते हो, it will bind with zinc, it will give red color. अब क्या होता है, आप टाइट्रेशन स्टार्ट कर रहे हो, EDTA very strong, it will break the metal indicator bond. जैसे ही ब्रेक हो जाता है, अब EDTA will go and bind with your zinc, and क्या होगा, आपका जो इंडिकेटर है, it will separate out and become free, and it will come to its original color, that is yellowish. This is what is happening. So far, do you have any problem in understanding? Did you get what this, how we are performing this practical? Sorry, did you say anything? Is it clear?
क्लियर मैम, बट एक क्वेश्चन है।
हाँ हाँ।
हम जब एग्जामाइन डालते हैं जिंक को पर्टिकुलरली फाइंड करने के लिए, तो एग्जामाइन का रिएक्शन क्या होता है? मीन्स कैल्शियम तो वहाँ पर प्रेजेंट होता ही है, तो क्या
रिएक्शन
एग्जामाइन?
नहीं है वो, रिएक्शन में पार्टिसिपेट नहीं करता है, इट इज जस्ट टू मेंटेन द पीएच। जैसे पहले आपने बफर डाला पीएच मेंटेन करने के लिए, एग्जामाइन भी हम पीएच मेंटेन करने के लिए देते
ओके मैम, तो 6 pH पे कैल्शियम बाइंड नहीं हो सकता क्या?
हैं। नहीं,
क्या उसके लिए
एव-
पर्टिकुलर पीएच चाहिए?
अलग है, कैल्शियम के लिए अलग पीएच। हर एक मेटल के लिए एक स्पेसिफिक पीएच होता है बेस्ड ऑन द पीके वैल्यू, तो मेटल टू मेटल ये चेंज होगा।
ओके मैम।
ज्यादातर एसिडिक पीएच पे मेटल्स कम बाइंड होते हैं, ज्यादातर ऐसा होता है, यू गो टुवर्ड्स द वीक एसिड और द बेसिक पार्ट, ज्यादातर ऐसा होता
ओके, थैंक यू मैम।
है। Anyone else is having any problem? We'll show you in your practical, the scanned practical. We'll show you this how it is, and I'll tell you about the calculation also. Anarga, could you please share this particular experiment?
Yes, I'll do.
Meanwhile, others, do you have any question about what I explained so far? Nobody is having any problem.
Ma'am,
Anarga, the scanned journal. Yes, they were sick.
ma'am, as you say, pH control is very important during complexometry titration. So, if zinc is bind at pH 6, acidic medium, and calcium is bind, we are taking mixture of sample. First part, at that time, calcium and zinc both bind at pH 10. Is it possible to perform only zinc at pH 10?
It is actually, see, I won't say it is not possible, provided you find something to mask calcium. First of all, you mask the entire calcium, make sure that it won't interfere, then you can continue with it. Otherwise, it is not possible.
Okay, ma'am. Thank you.
Okay, so everyone you can see this journal, everyone?
हेलो मैम, आई हैव
Yes,
वन
ma'am.
क्वेश्चन।
Yes, Nick.
अकॉर्डिंग टू फर्स्ट में हम जब कैल्शियम और जिंक दोनों बाइंड होते हैं, उसमें से फर्स्ट कौन बाइंड होता है? क्योंकि आपने जैसे बोला कि हमें किसी को पहले मीन्स का हम कैसे बोलते हैं कि किसी को हम साइड में कर दे तो ही जिंक को हम प्रिसिपिटेट कर सकते हैं 10 pH पे, राइट? तो क्या कैल्शियम पहले बाइंड हो जाएगा, रिलीज होगा ईबीटी से, कि जिंक होगा?
एक मिनट, मैं नहीं समझी। Could you please
हम
repeat it?
हम जब इंडिकेटर ऐड करते हैं ईबीटी, अकॉर्डिंग टू यू से कि फर्स्ट हमारा जो ईबीटी होता है वो कैल्शियम और जिंक के साथ कॉम्प्लेक्स बनाता है,
हाँ,
राइट? व्हेन वी एडेड ईडीटीए फॉर टाइट्रेशन, व्हिच वन इज लिबरेट फर्स्ट? कैल्शियम और जो ईबीटी का जो बॉन्ड है वो फर्स्ट ब्रेक होगा, या जिंक और ईबीटी का?
इसके लिए है ना, देखो जैसे मैंने फॉर्मेशन कांस्टेंट के बारे में बताया ना,
यस मैम।
तो अब हर एक मेटल का सिर्फ मेटल नहीं, मेटल का जिसके भी साथ कॉम्प्लेक्स बनता है, दे हैव अ स्पेसिफिक वैल्यू। एवरी मेटल इज हैविंग अ स्पेसिफिक वैल्यू। जैसे कि अगर कैल्शियम ईडीटी है, ईडीटीए है, तो इट हैज अ स्पेसिफिक वैल्यू। Similarly, any metal has a specific value. For your answer, I will have to look into that specific values. I don't know the exact values. Based on the values, we can test which one goes first and which one goes second.
ओके मैम, बट व्हेन अगर हमारे वाइवास में हमें क्वेश्चन पूछा जाए कि इसमें से कौन सा फर्स्ट रिलीज होगा, तो हम क्या आंसर दे सकते हैं?
देखो इसमें है ना, तुम्हें थोड़ा बेसिक क्लियर करना पड़ेगा. You will have to go through some reference book. We can suggest you the reference book. You will have to go through the basics. जैसे वोकेल है. हाँ
अर्चना में आए,
यस।
मैं बोलूँ?
हाँ 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 हाँ, श्योर श्योर प्लीज.
हाँ हाँ, देखो उसमें क्या होता है ना, फॉर्मेशन कांस्टेंट जिंक का इज मोर स्टेबल कॉम्प्लेक्स. जब जिंक का कॉम्प्लेक्स बनता है वो मोर स्टेबल कॉम्प्लेक्स बनता है, इसलिए पहले जो भी कॉम्प्लेक्स बनेगा पहले जिंक के साथ बनेगा, देन कैल्शियम के साथ बनेगा.
ओके मैम।
इज माय स्क्रीन विजिबल अर्चना?
Yeah, your screen is visible.
ओके.
Uh, but yeah. So and you are able to see the this scan journal.
हेलो मैम, कैन आई अगेन वन लास्ट क्वेश्चन ऑन
Yeah,
माय
yes,
साइड?
sure, yes, sure, sure.
जैसे मैम ने बताया कि फर्स्ट जिंक के साथ बाइंड आउट होगा,
हाँ,
राइट? तो जब लिबरेट होगा तो कैल्शियम में फर्स्ट कैल्शियम से लिबरेट होगा ना, अकॉर्डिंग टू मैम से इसकी उसकी स्टेबिलिटी ज़्यादा है वो ईबीटी के साथ, तो वो फर्स्ट बाइंड हो गया। तो जब हम उसे ईडीटी के साथ रिएक्शन करवाएंगे तो फर्स्ट कैल्शियम लिबरेट होगा ना, क्योंकि उसकी स्टेबिलिटी ज़्यादा है, तो
हाँ हाँ
नहीं,
हाँ, करेक्ट है.
राइट मैम?
राइट राइट.
ओके मैम।
Anarka,
यस अर्चना.
there was a question.
सॉरी आई कैन नॉट हियर यू. क्या बोल रही है?
कि निखिल का एक और क्वेश्चन था.
अर्चना आई कैन नॉट हियर यू. आवाज़ ही नहीं आ रही है.
Can you hear me now?
यस 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 यस.
Yeah, I was saying Nikhil was having one more question. Did you hear that?
Which question? The one he was asking right now, that which complex will liberate first?
हाँ, हाँ.
Yes, yes, calcium will liberate first because the calcium
Okay,
complex is
so you gave the
less.
answer because it got stuck in between.
I gave the answer. Okay. So shall we continue with our journal, scanned journal?
We can continue with it.
Okay, okay. I guess my screen is properly visible to you all. So Archana, you may continue.
Yeah. Okay, so everyone, you can see this. This is how you will you be actually um, note the journal once the practical is done. So this was your aim. Simultaneously, you have to find calcium and zinc, and you can see the solutions that I mentioned. Now you can specifically see which all solutions of how much concentration we are preparing. आप पूछोगे कि ये 0.01 और सब आपने कैसे कैलकुलेट किया? These are all calculated and prepared through trial and error method. So all this has been fixed and kept. Now you can see the procedure also. Anurag, could you just move a little down? So you can see the procedure part A, which is for both the metals. So this is the exact thing that you have to perform in lab, uh, as it is given. Taking 10 ml, 10 ml, I mean, just following the entire thing, it is exactly what I was talking about. So once you complete with the first part, whatever burette reading you get, you mark it as XML, you will get some reading, right? So you will mark it as XML, and you continue with the titration of part B, which is, like I said, exclusively for zinc. अब जिंक में आप देख सकते हैं कि वी आर यूजिंग हेक्सामाइन. It is written, add sufficient hexamine to get pH 6. So you add hexamine and then perform the titration, and finally whatever reading you get, you mark it as Y. Now we are having two burette readings, X and Y. We'll proceed with the calculation. Okay, you can see over here, um, it is expected that your X value will be always more than Y, क्योंकि first part में you are determining both, दोनों metals है ना, so obviously more EDTA will be used up to bind with both the metals, so the value will be more. And second case में आप देख सकते हैं the value is less because that is only for your zinc. अब आपको पता है कि जिंक के लिए इतना ml है. Alright, for zinc you got 5 ml, right? So you have a standard equation to find out the value. As you can see, last time you were told how to do the calculation when we want to find out how much of a compound is present. So we have a standard equation. अगर आपके पास 1000 ml 1 molar standard EDTA है, so that is equivalent to 65.39 grams of zinc. This is standard. अब आपने जब प्रैक्टिकल परफॉर्म किया एंड burette रीडिंग बाई ml है, एंड आपका EDTA जो आपने प्रिपेयर किया है वो है 0.01 मोलर. In that case, how much zinc does it have? So all you have to do is cross multiply and you get the answer. आप देख सकते हैं कि your unknown sample, that is in that at that particular point of time, when this is Anarga ma'am's journal. So when ma'am was performing in lab, you can see that mixture that ma'am was given, it had 3.4 milligram of zinc in the unknown solution. मैम ने 10 ml सैंपल लेके इंटायर प्रैक्टिकल परफॉर्म किया, तो उस 10 ml में that 10 ml of unknown sample had 3.4 milligram of zinc. Now moving forward, आपने जिंक ढूंढ लिया, आपको अब पता करना है कि कैल्शियम कितना था उसमें. So now you know, you have the reading for calcium and zinc, you have the reading for zinc. So all you have to do is subtract it, and whatever remains is the ml of EDTA used for calcium. So जैसे कि आप देख सकते हैं, we just subtracted x minus y and put that value over there in the equation. Follow the equation, cross multiply it, and you will end up with, you will find out how much of calcium is present. So again in this you have the standard equation. अगर आपके पास 1000 ml 1 molar standard EDTA है, so that is equivalent to approximately 40 grams of calcium. Based on that standard equation, so you can see that time and during that practical it was found out in the 10 ml of unknown sample, 10 ml of mixture, 1.8 milligram of calcium was present. So you see how it is determined. You are having a mixture in that this much amount zinc was present and this much amount of calcium. The calculations are very simple, and this is how it is done. Okay, we'll again look into the lead magnesium part also. So I told you these two practicals run parallelly. They are entirely same. Everything is same. So if you look at it carefully, you can see you are having your part A, where your sample having magnesium and lead both are titrated. Again इसमें same है. Part A में EDTA will bind with magnesium as well as lead. the pH is 10. In the second case, जैसे कि in previous practical आपने perform किया exclusively for zinc, अब इसमें your part B is exclusively for lead, जो आपका 6 pH है. In that you will you can bind your EDTA exclusively with lead, and the remaining things are just the same. अगर एक बार आपको पता चल जाए कि मैग्नीशियम लेड के लिए इतना ml यूज होता है एंड एक्सक्लूसिवली फॉर लेड यू हैव डिफरेंट वैल्यू, just subtract it and you will come to know how much ये was for your magnesium. So, could we go to the calculation part, Anarga? Okay, again you can see here a little bit top, Anarga, where they can see the values. Okay, आप देख सकते हैं कि the first part A, where we named it as XML, will be obviously more in value than Y, because more EDTA was consumed, क्योंकि it had to bind with both the metals. Second case, आपका EDTA is just binding with your lead, so the value will be comparatively less. Whatever was used for lead will be shown. You can see both the values. Moving towards the calculation, uh, so you know by ml, जो भी आपने by ml मार्क किया है वो that is exclusively for lead. आपके पास एक standard equation है, 1000 ml of 1 molar EDTA, standard EDTA, it is equivalent to 207.2 grams. So when you put your values, whatever Buret reading you get, by ml आपका जितना भी है, आप जैसे ही डालोगे, you will get the amount of lead that was present in your amount. अब जब ये एक्चुअल में परफॉर्म करते हैं, every student has different values of each metal. Everyone, the mixture is prepared in such a way that everyone gets different values. So as you can see, when this practical was performed years back in lab, at that time 10 ml of sample that was given to them had 14.2 milligram of lead in it. Similarly, for magnesium, same thing. When you have a total and you have one known variable, just subtract it. You put x minus y value, that much ml of ETA was used up for magnesium. So put those values. Now you can again see over here 1000 ml of 1 molar standard ETA is equivalent to 24.305 gram of. Put the values in the equation and you can see that again in that time the solution that was prepared had 10 ml solution contained 0.51 milligram of magnesium. You can see 0.51 milligram yani 1 milligram itself you cannot weigh. So just see 0.51 milligram of magnesium was present in that. So this is about calculation again as simple as that. See, there isn't much of it. So this is how we note down the practical in the journal, and that is about simultaneous determination. 4 minutes. Anyone has any doubt? I think we can show you the videos. Another, I think we can. Shall we show them the? Okay, this is for calcium, right? Anybody is having any problem so far? I guess no issues. So then we'll continue with the video analysis.
Hello folks, I'm going to demonstrate here a calcium EDTA titration just like would be specified in our quantitative analysis lab. So let me quickly show you the experimental setup here. I've got a couple of urets set up here. The one on the left here contains the calcium aqueous unknown. So for this particular trial, I have actually measured some of that out. And what I have here for this trial is an initial volume of 0.25 milliliters of that solution, and then I ended at 20.45 milliliters of the solution. So that's actually what I have in the Erlenmeyer flask right here. And I've also added 2 milliliters of the very stinky ammonium chloride buffer to that. So that's already been done. So at this point, I'm going to set the camera up here close by so you can see the titration. And I'm going to go ahead and add the last couple of reagents that we have to put in. So the next thing I'm going to put in is going to be 5 drops of the Areochrome black tea indicator. As you can see here, that's a very pretty red solution. And there's a 5th drop, just in case. All right, so I'm going to stir that up. You can see what that looks like. Looks like sort of a nice bright pink or reddish pink solution there. And then the next thing we're supposed to add is 10 drops of the magnesium EDTA solution. So that turns out to be about a dropper full, but we'll go ahead and count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll get that last one, 10. There we go. All right, so at this point, I'm going to go ahead and shake this up nicely, make sure we're in good shape. So now what I need to do is get an initial volume on this burette, which I'll quickly do. So I have a paper towel here and I can read it. So it looks like I'm right at 0.00 on the burette. All right, so now we're going to begin the titration. The nice thing about this is that we can add the titrant pretty quickly. Initially, I found that in the last titration that I did, I added about 15 and change milliliters to this. So I'm using a little bit bigger volume this time, so I know I can put about 15 milliliters of titrant in pretty quickly and then sneak up on the endpoint. So let's do that. So I'm going to go ahead and bring the burette just up a tad, and I'm going to go ahead and start adding the titrant fairly quickly. Now at this point, I just want to swirl, and I'm going to keep my eye on the burette to make sure I'm not putting more than about 15 milliliters of titrant in, because then we're going to slow the titration down after that and make sure we can sneak up on that endpoint. So far you really don't see much of a change or any change in color, and that's to be expected. Now what we're looking for, again, to remind ourselves, is we want to see a transition from this pinkish color, reddish pink, through a purple, and then ultimately to almost a sky blue. So that's what we're trying to get in this titration. So we're going to come down to about 15.5 mils, and then we're going to sneak up from there. We have a little bit of ways to go yet. Okay, we're almost there. So we'll go to about 15.5 here. There we are. All right, so we'll just take a quick assessment of our color at this point. Now you'll notice that the color seems to be maybe just a little bit darker, so I may be approaching the purple, but I still have a little ways to go. So we'll go sort of drop-wise, or a few drops at a time at this point. So I'm going to set my burette up to slowly deliver a drop or two at a time. And then we have to also keep in mind that the reaction tends to be kind of slow at the end point. So we want to make sure that we have time for each drop to react before we add another. So that's why I have a very, very slow drop going here. Okay, when I see that purple start to develop, I'm going to stop. Okay, it looks like I'm about there. Okay, you can actually see that change now that I've gone almost from a pink to more of a purple. So it's a little darker yet, so I'm really going to slow down and go dropwise at this point and see where we end up. There's a drop, so let's see how we look. Perhaps a little bit darker. We're pretty close at this point. I see more purple in there now than I did before, so maybe another drop or two should do it. There we go. Ah, you can nicely see that purple, and we'll catch that last little bit that went in. Oh, there's the blue. All right, so that's what a good endpoint looks like. We've seen how we've gone through the reddish pink, through the purple, now to what looks like almost a sky blue. So I'm going to get that last burette reading here. And it looks like I'm at 60.20 exactly. So I've recorded that value. So at this point, this is what the titration is going to look like. So I'm going to end up feeding you data for all 4 of the titrations that I did so that we can then work them up. So that's something to do for another class period.
Good morning. The experiment that we are performing is estimation of zinc ions in 250 cm cube of solution, unknown solution, using EDTA. Okay. Now this involves 3 steps. First step is preparation of standard solution of zinc sulfate. Second step is standardization of EDTA solution, and the third step is estimation of zinc. Okay. Now we will start with the first step. We will prepare the standard solution of zinc sulfate. For this, I have taken approximately 3.6 grams of zinc sulfate in a weighing tube. I am going to keep it on this balance. See, whatever weight I get, I note down here. Now this is the weight along with bottle. Okay. Now I am going to transfer this zinc sulfate crystals into the standard flask completely onto the funnel which is on the standard flask. Okay, completely. Afterwards I close it. Okay, ensure that the reading is 0. Keep it again and take the weight. So it is about 9.19. So the difference in the 2 weights will give you the mass of zinc sulfate that is taken here. Okay. Next step is we have to dissolve this in water. So I am going to dissolve this in water. For that, what I do is, see, I lift the funnel slightly, put some water on this, so that the solid is completely transferred into the flask. After it is transferred, I put a little excess of water so that all the particles sticking to the surface of the funnel go down, and I am going to clean the lower part of this funnel and keep it aside. Okay. Now I have to ensure that the crystals that is inside the flask is completely dissolved in water to form a solution, and that solution will be a solution of zinc sulfate, and I can take it as standard solution because I will be able to calculate its molarity using the weight of zinc sulfate that I have chosen. Okay. I have to ensure that it completely dissolves. Once it is completely dissolved, no solid particles are seen. I can fill it full with water. Okay. I am going to add distilled water to the maximum. That is, it is indicated by a mark. Now I will shake it thoroughly again. Shake it thoroughly again. Okay. So now this solution is ready. This is standard solution of zinc sulfate. Now I am going to take a conical flask, pipette out 25 ml of this solution. Okay. Before I pipette out, I must rinse this pipette with a small quantity of the solution. Okay. Take a very small quantity of the solution. Rotate the pipette all around so that the solution will stick to its walls everywhere. Now throw it back into the sink. Okay. Now dip it in the solution and pipette out. Right. So use this finger. Which finger? You can see there. Right. Hold it tightly. Remove the pipette outside the level of solution. and slowly release the finger so that it goes down and reaches the mark. So now it is ready. I will transfer it into the conical flask. Don't blow it, just allow the solution to flow on its own, and in the end, tilt the conical flask to one side, touch the pipette 2 times to the upper clear surface, so that a little amount of liquid will be left here. Okay, you can ignore that. The pipette volume is 25, excluding that part. Now, this solution, I have to add about 3 ml of buffer. So this is ammonia chloride buffer. I need to add about 3 ml of it. Okay. Need not be very accurate, but more or less it is okay. Roughly around 3 ml we need to add. And then add a pinch of the indicator. Now this is eriochrome black indicator. This is eriochrome black made into, let us say, a dilute solution, solid solution, by mixing it with sodium chloride. Okay, add little of the indicator and ensure that you can see that violet color. Okay, it is the wine red color. Okay. Now I'll start the titration. Okay. This solution has wine red color. Now I have to titrate this against this. Now what you have in the burette is the EDTA solution, that is whose concentration we need to know. Its concentration is not known to us. So we need to find the concentration of this EDTA. Now this EDTA is nothing but disodium salt of EDTA dissolved in water. Okay. Now I am going to run down this slowly. Slowly, you can use one left hand for rotating this knob and right hand for continuously shaking. And you need to swirl the solution around. Okay, and you can see that the solution color is wine red. It should change to blue near the end point. Okay, let us add slowly with constant shaking. You will know that the end point is approaching. The color slowly becomes light. Right. Now it is complete. You can see the wine red solution has changed into blue. Now this is the end point. Okay. Now record the burette reading. Record the burette reading. It is something like 20.2, 20.6, sorry, 20.6. So record this burette reading and I will tell you about the calculation later on. Okay. Now, in the second part, what I must do here is, generally what we do is, we give you a standard solution of this one. This is actually a standard solution of zinc sulfate prepared by us, but for the students this is unknown solution. Its concentration is not known. What we normally do is, we pipette out about 25 ml of this, roughly around 25, it can be anywhere between 20 and 25. Mark is on the rear. Okay, I have chosen 25 ml. I'll take it in this standard flask. Now in the examination, what is normally done is the examiner gives you the solution of a varied volume between 20 and 25. Okay. Now the student will have to take it as unknown solution. The volume that is given will not be known to the students. Now I have taken, let us say, about 25 ml of this, and that is for the part 3 for estimation of zinc. This is the unknown solution. Now I am going to make it up to the mark by adding distilled water. You have to be very careful here while adding water. Ensure that you don't go above the mark. I forgot to mention in the first part. I am telling you here, you have to be very careful while adding. See, you can add up to the rim, okay, faster, and beyond that you need to be a bit careful. Keep the mark to your eye level. Add it drop by drop. See? One drop at a time until it reaches the mark.
Anara, could you pause for a moment? Okay, students, I want to highlight something over here. What you see in this professor's hand, in the left hand, we call it a volumetric flask, something that you see with a long neck and kind of round bottom. That is called a volumetric flask. Whenever you perform this practical in your exams, this is just for your understanding. See, uh, we can show you um, these kind of videos, but certain things we have to um, certain things which you for which you don't have access, just to make you understand that. What you see is a volumetric flask. So what happens when you perform this practical in your exam? आपका जो unknown sample है, there will be a liquid solution having unknown sample, जिसमें दोनों metals होंगे. आपको ऐसा flask दिया जाता है. Everyone will be given different flask. Now this what you see on the screen appears to be, I guess 250 ml or something like that. So you will be given something like 50 ml या 100 ml flask आपको दिया जाता है, and उसमें you will have unknown solution. Each student having different amount. You are then requested to fill the flask, dilute it with distilled water, just as you see this professor doing. He is filling up the flask. This particular volumetric flask, आप वो जो आप नेक देख रहे हो, it is having certain mark on it. वहां तक आपको dilute करना होता है. And you have to be very careful in it. You must have observed how he is taking time and diluting the entire solution, because if you add even a little extra of water above the mark, the concentration will change and the entire reading will go wrong, because this is the first step. This is the first step. This is your unknown solution. अगर आपने unknown solution itself गलत concentration का बनाया, then your entire practical goes wrong. So I'm just letting you know these kind of things are also there. और एक बार ये solution बन जाए, this volumetric flask जिस पे वो जो neck region है, there is a mark, and जैसे ही आप वहाँ तक पानी ऐड करके dilute कर लेते हो, that becomes your sample of analysis. And बहुत बार ऐसा भी होता है कि students what do they do, अब इसमें से आपको sample collect करना रहता है for your titration. अब ये entire sample एक साथ आप titrate नहीं करोगे ना, you just have to take 10 ml from it and start with the titration. तो आपको 10 ml कैसे collect करोगे? Mostly you have to collect it using a 10 ml pipette. तो आप 10 ml pipette से जैसे collect करोगे, many students, like some students actually find it difficult उसमें pipette डाल के collect करना, they find it difficult. So what do? ये जो वॉल्यूमेट्रिक फ्लास्क में जितना भी सोल्यूशन बनाया उसको ट्रांसफर कर देते हैं बीकर में, which is very wrong. Once you are given once you are given a volumetric flask, Anarga, could you please keep sharing that? Once you are given a volumetric flask, do not transfer your sample to anything else. That leads to error. Or you have to take out your unknown sample every time using a pipette only. Then we'll continue with this. Could you please continue, Anarga?
Few drops are required. Okay, inlet here. When you make it up, what you have to ensure is the lower meniscus, that semicircle, right? That is the mark of the solution, should be just above the line. Okay, we must be able to see that line. Right? Now it is perfect. Close it with a stopper. Okay, turn it upside down, shake it thoroughly, do it 2 or 3 times, and ensure that it is thoroughly mixed. Okay, now this unknown solution is ready. Okay, remember the first one, we prepared zinc sulfate solution using zinc sulfate crystals. Okay, you have weighed that zinc sulfate crystals, so that means you know the mass of zinc sulfate, you can calculate the molarity of zinc sulfate. Now this zinc sulfate solution is unknown solution, it is given to you in the standard flask, and the volume what is given is known only to the examiner. You don't know it. Okay, it is the examiner's prerogative to give you a definite volume depending on the solution which he has prepared, okay, he or she has prepared. Now I have to perform another titration now with this unknown solution. Okay, first time I did only one trial. Actually you are supposed to, let us say, take at least 3 trials and ensure that you get 2 concordant readings. Same thing I am going to tell about this. You will have to perform at least 3 trials so that you get 2 concordant readings. Now what I am doing here is I will perform one trial and show it to you. And remember, I have used a different pipette which I have not used in the first part. Okay, the pipette I use in the second part should be different from the first one. Otherwise, the pipette, if I am using the same pipette, I need to clean it thoroughly, then rinse it with distilled water, rinse it with the same zinc sulfate solution, and then use it for pipette. Okay, so finally, I touch the upper part of the conical flask, so that now it is completely taken inside the conical flask. Now I have to fill the burette, because every time when I start a titration, we need to start from 0, because we will have a uniform error. So now it is 0. Now to this zinc sulfate solution, in a similar manner what I did first, I must add roughly around 3 ml of buffer solution. That is prepared by using ammonia and ammonium chloride solutions. Okay, then I am going to add indicator, few crystals, so that the color of the solution turns wine red, not very dark, not very light, somewhere in between. Now I can do the titration similar to how I did in the first one. Okay, so I will start adding it into this solution, and you know what is the end point? The wine red should change to blue.
Anarga, your system is muted.
क्या बोल रही है?
म्यूट हो गया था.
पूरा ही म्यूट था?
नहीं नहीं, लास्ट फ्यू मिनट.
हाँ, वो मैंने बंद किया, वो कैलकुलेशन अपना और उनका थोड़ा डिफरेंट है.
ओके ओके.
हाँ हाँ, तो we shall move ahead with FECR practical, right? Because magnesium and lead is of almost same type.
All right. So the titration, since it is over, we can continue with this.
Yes.
Before that, anyone is having any problems in this?
Hello, Archana, you want me to show the scanned journal or the video?
Scanned journal of?
FECR?
No. I think we will do the other one, and then once the explanation can how they.
Okay, you may continue. Hello, Archana, you're muted.
Yeah, actually, I was setting.
Okay, fine, yeah.
So we'll continue. Now, yeah, before continuing, what you saw was of calcium and zinc, and magnesium lead follows the same thing. In case now, say today, all of those, since it is everything is same, we are not repeating the videos of the remaining two. But if you need it, if you want to watch, just let us know. We will share the links with you, and you can see it. It is exactly the same. Uh, Also, another thing, we showed two different videos for both the metals. Now, that is a case where they are individually performing for single metal, single single metal. What we are doing is, what is our aim? Our aim is simultaneous determination. So, the system that we are dealing with, it is having both the metals together. But the method remains same. That is how you have the method, the principle, the mechanism. It remains same. So that is how you perform it. Even if you have two metals or single metal, it remains the same. So that was about the video, and the other two, if at all needed, just let us know. We'll share the links. There's absolutely no problem in that. So now we'll move ahead to the third practical, which is again in the same category of complexometry. But now there's a slight difference in this. You see, this particular practical that now we are dealing with, it is we are determining a mixture of Fe and Cr, iron and chromium. Now, these two metals we want to determine simultaneously. So if we follow the previous method that we had, the previous protocol, we won't get result in this, because you know every metal has got its own property. There is some kind of difference. They won't react the same way under same environment or same conditions. For certain metals, you will have to uh, change the environment to make it bind with the EDTA and form a complex. It's just like uh, you have to deal with different people having different personality differently, right? Everyone is different, so every metal is also different. So you have to find out uh, find out a specific method to deal with uh, the specific metal that we are interested in. This is the case where we have Fe and Cr, and this titration involves the principle of kinetic masking. Kinetic masking. So what is this? Previously, if you observed in the last two cases, we saw that everything was taking place at room temperature. You just changed the pH. Other than that, आपको कुछ करना नहीं था. You just had to follow the normal protocol of adding something and mixing things, and you got it like EDTA formed complex, and things happened. But now there are certain cases where simply adding things won't work. You will have to give something extra to make to form the bond for complexation to take place. So you need to give something extra. What is that? In this case, iron is a metal that is capable of forming complex with EDTA at normal room temperature. It can form a complex. It's fine with iron. But chromium is pretty inert at room temperature. If you simply mix with EDTA, it won't bind. It is like one of those very patient people, so it won't easily bind. So what you do, how do you test a person's patience? By bringing in additional extra forces. Same thing. What we do is we just irritate chromium by giving it some temperature, and we will forcefully make it bind with EDTA and perform the titration. So this is the main difference in this one. You cannot directly perform it under room temperature. So how do you perform it? Now this is a typical case of back titration. You all have heard the word back titration? Indirect titration, back titration. Have you heard of it?
Yes, ma'am.
Yes. What is that?
Ma'am, in back titration, the reagent which is used, we are during titration is added already in excess. So the analyte which we are want is bounded with it, and excess sort of that reagent can be determined. So we know the initial concentration or initial volume, and we take a it's difference, and without analyte, we added same amount of that, and with in that what analyte consumed and what blank is given. Typically, we are talking about the sulfate titration. So in that case, we use that barium chloride. So barium is formed barium sulfate, and without sulfate analyte, barium chloride is remain as it is. So with the help of difference, we determine the amount of sulfate in back titration.
Yeah. So you have an idea. You have done something sort of back titration in your SEM 1. Everyone, if you could recall this particular sulfate precipitation titration, if you recall that was a case of back titration. Back titration or indirect titration is again something where you do not take the titrant in the burette. You don't perform directly. Instead, what you do is you take excess of it and directly add it into your sample of analysis, a known sample. Excess, it has to be. This is one important condition for back titration. It has to be excess. Put it in excess quantity, and then you follow some protocol, and then you are good to go. You get the results. So what happens in this is what happens in this case is we are going to adopt back titration. So what you do again, we start by preparing the solutions. We have a mixture containing Fe plus 3 solution, Cr plus 3 solution. That becomes your unknown sample. Please hold on. Fe+3 solution, Cr+3 solution, we also need EDTA solution. And since this is a case of back titration, we need one more uh, solution, that is we prepare lead nitrate. The titration is done against, once we prepare the environment in the conical flask, after that we need to perform titration also. So that is lead nitrate we prepare, which we fill in the burette. Indicator used over here is xylitol orange, and in order to maintain the pH we need hexamine. We will be working under pH 6 conditions, so hexamine will be needed. So these are the primary requirements. Okay. Now this particular practical is divided into three parts. The first part includes we need to perform a blank titration. Now you all are aware at this stage, you all are aware what a blank titration is. You take all the ingredients, like all the reagents which you need for the titration, except your sample. Except the sample, everything else you take, do the titration, whatever you get, the reading is blank reading, that becomes your first part. Then we go to the second part where we detect the amount of Fe present in the solution. Only Fe, exclusively Fe. Then we move, then we move on to the third part where again the scenario changes, and we follow certain protocol and we find out exclusively chromium present in our sample. So this is divided into three parts. I will start with Fe followed by chromium. Uh, Once these two are clear to you, then this blank will be definitely, you know how to do the blank. Everything is same except the sample. Everything you have to take and perform the titration. So this is how it is. You take your sample. आपको जो sample दिया गया है जिसमें iron भी है and chromium भी है. You take it 10 ml. You add about 20 ml of distilled water to it. Now see, I told you Fe can bind with EDTA at normal room temperature. So everything will go at room temperature in this particular case. आपके पास sample है, distilled water add कर दिया है. Now you will add excess of EDTA. अब ये जो excess है, excess मतलब कितना, how much to add? This has been tried and tested through trial and error method, and we have found out that हम जो लैब में करते हैं, in that case 20 ml of EDTA is sufficient, is excess for us. 20 ml of EDTA is fine. So EDTA add कर दो 20 ml in your conical flask. Now we will go ahead and set the pH. So we will add hexamine. We will see to it that pH of 6 is maintained. Indicator, xylitol orange indicator you add. Now all the while, whenever you are adding anything new, you have to keep in mind, you have to constantly shake your this thing, conical flask well. You have to keep it shaking very well, because we have observed in lab some students, maybe they might not be, you know, present there mentally or somewhere else. It happens. They will add things and simply keep on adding things. Now you add something, it gets deposited at the bottom, no reaction is taking place. How do you expect results to come? So every time you add something, whether it is something for the pH, whether it is your indicator, whatever you add, keep shaking the conical flask thoroughly. Because when you see in one of the coming videos, you will see that they have preferred this thing, a magnetic stirrer, which is good, but we don't use that in our lab. We just mechanically shake it with our hands. So the shaking part is also important. Okay, now you added everything, whatever was required, and then you begin with the titration. So like I said, we have lead nitrate solution for titration. Okay, now in this particular case, when you add xylitol orange and when you perform with the titration, the final end color is yellow to red. So what happens in this is a back titration. You remember, So what must be happening over here? Can anyone tell me what might be the scenario over here? I think I'll go ahead. Okay, see, what is our aim? We want to find Fe. In this case, we just want to find how much ferrum is present inside our sample. We know our sample is containing iron. We added EDTA, excess EDTA. So what will happen under the normal circumstance, room temperature, EDTA will go and selectively bind with Fe atoms, Fe ions present in your sample. Say you added 20 ml EDTA, right? You added 20 ml EDTA. Your sample might be having some amount of Fe. अब क्या होगा, based on the amount of Fe present in your sample, मान लो कि 20 ml में से 8 ml या 9 ml of EDTA was used up in binding with Fe. 20 ml आपने जो excessively डाला है उसमें से मान लो कि 8 ml got bound with Fe. अब बाकी जो 12 ml EDTA है that is in free form, right? Now, how to find out how much of EDTA is present without complexation with Fe? ये आपको find करना है. To find this, we are performing the titration with PbNO3. Now, lead is again a metal that is very good in complexing with EDTA, so you perform the titration and you can come to know how much extra EDTA was present after the binding of EDTA Fe. This is what is happening. So you see the back titration. From the answer, you go back to the question. You're going it in the indirect way. This is about the back titration. Now this Fe part was pretty simple. There was nothing much to it. Almost similarly, almost same thing. Coming to chromium, it becomes, now chromium is very inert in nature. Under normal circumstances, it will not bind with your EDTA. So we need to give it some extra forces, some extra energy. We need to change the environment a little more to make it forcefully bind with EDTA. So what do? We take our mixture. The mixture is having Fe and Cr. Okay. Dilute it with this is water. Now we will add what we our first step is we will make the solution acidic, about 2 pH acidic, and in order to make it into 2 pH, what we will do is we will add 1 molar HNO3 nitric acid. 1 molar yani it is pretty concentrated, काफी concentrated है 1 molar, and because it is pretty concentrated 1 or 2 ml of HNO3 is sufficient. So you add HNO3 nitric acid to the sample and make sure using your pH strip, the pH is maintained about 2 pH now. Once this is done, you heat it. Now heating is again a very important part. You have to heat it up to the point that it slowly starts boiling. Up to that part, slowly bubbles come up. Up to that part, you have to heat it. Take it down. Then you add EDTA to it. जो excess में हम डालते हैं 20 ml. Put that EDTA. Remaining things are the same. You add hexamine. Again, now you will have to add more hexamine because 2 pH पर से आपको फिर से लाना है 6 pH. So add hexamine accordingly, and then you add the required. Then you add the required amount of your indicator and continue, and you proceed with the titration. Again, you will find yellow to red color. The only change over here was For a metal that was kinetically inert, for a metal like chromium, which is kinetically inert, we are providing it thermal energy and bringing it to a state where it becomes, where it is in a position to bind with your EDTA. That is the change over here. Calculation part more or less remains the same. We will look into that. Anara, could you please share practical? Meanwhile, do you have any doubt? Anyone wants to ask anything in this? Yes. Somebody wants to ask something? Okay. Yeah. This is the actual practical. Now see, the scanned journal we will be showing you, but there's been a slight variation in the procedure that we do. So the procedure given in the scanned journal do not follow that because of certain conditions. We just optimized the entire procedure, and when we perform according to this particular printed notes that you see over here, you will get the exact practical. Now, okay, could you move a little uh, down, Nanda? I told you about part B and part C, right? Uh, Along with will perform the blank calculation also. Will perform the blank calculation also. Now in blank, you know that um, everything is you take all the ingredients that I mentioned. EDTA you have to take at your indicator, just the same. Everything except the.
Ma'am, your voice is not clearly audible.
Is it audible now?
Yes, ma'am.
All right. So yeah, I was just telling you the blank that you have to take. You can see over here how the procedure is done. This is exactly the same thing that I was talking about. Now this particular PDF we will be sharing with you. For the procedure, follow this one because uh, what is given in the scanned journal, there is some correction to it. So this is your procedure. Anara, could you just go down a little more? Okay, before that, let me tell you, your blank reading is BML. Just for the sake of calculation, I'm telling you. Blank is B, your FE is XML, and your chromium is YML. So you can see that over here, when you're performing the, when you're calculating, you can see over here, it goes the same way. I think this will be more clear to you in your scanned journal. We just have to follow the same thing. Okay. There might be a certain confusion about chromium. You can see B minus Y minus B minus X. It is basically you just have to minus the iron, the amount of uh, EDTA for iron uh, with that of chromium. Just look at the X minus Y part. There's nothing, otherwise the previous thing might appear complicated to you. So calculation remains almost the same. I think the journal would be more better. Can we shift to the journal, Anarga?
Is it visible?
Yes, it is.
Is my screen visible?
Yes, yes, it's
Okay,
visible.
fine.
Okay. Anara, could you go slightly above the top portion? Okay, okay. So you can see over here the calculation part. No, Anarka, the calculation part. The starting of the calculations. Yes. So you can see over here. Again, we have a standard equation. Now see the standard equations for all the titrations. Whenever you perform in your exam, the standard equation will be definitely given to you. Like जैसे कि यहाँ पे आप देख रहे हो 1000 ml 1 molar EDTA is equivalent to 55.845 gram Fe. अब ये जो values है, this is always given to you. You have to continue the second step according to your reading and the concentration of solution that you are dealing with. So the calculation is pretty simple. You just have to put in the values and follow the steps accordingly, and you will get the result. You can see over here the Fe obtained was. Should we go a little down, Anarka? So you can see over here once the calculation was done, the 10 ml sample contained 4.41 milligram of Fe. Similarly, we have a standard equation for chromium ions also, and once you put in the values for chromium, you end up with still a little more down, Anarka. Here it is. You end up with the amount of chromium present in your sample. The thing is, see, you have to put in the value, putting in the values and doing calculation. You always do correctly. What the students, the mistake that students usually make is, you can see over here the page that you are looking at. The second last step is in gram. You can see how much gram it is. First, you have to look into your question paper whether it is asked in gram or milligram. First, you confirm the unit. अगर ग्राम में पूछा है तो ग्राम में रखो, मिलीग्राम में पूछा है तो कन्वर्जन आना जरूरी है. ग्राम टू मिलीग्राम, हाउ मिलीग्राम टू ग्राम, हाउ इट इज डन. 1000 milligram becomes equal to 1 gram. So you need to know the conversion factor. ओके अब ये आपको पता चल गया कि ग्राम है मिलीग्राम है, एक बार वो कंफर्म कर लो. उसके बाद अब देखो, अगेन यू हैव टू गो इनटू द क्वेश्चन पेपर एंड यू हैव टू सी कि whether in have they asked you to find out in 10 ml sample or 100 ml sample. जैसे कि यहाँ पे आप देख रहे हो इट इज 1.35 मिलीग्राम इन 10 ml सैंपल. आपने जो भी टाइट्रेशन परफॉर्म किया 10 ml सैंपल को पिपेट आउट करके आपने परफॉर्म किया ना, तो आपका जो भी रिजल्ट है वो 10 ml का रिजल्ट है. अगर एग्जाम में आपका जो क्वेश्चन पेपर होगा उसमें पूछते हैं मिलीग्राम इन 100 ml, तो क्या करोगे आप? कैसे फाइंड करोगे? एनीवन?
Percentage find कैसे 1.35 to 10 ml, then 100 ml, how much?
Very good. Yeah, it is very simple. Exactly like this. But students often get confused and they, fail to make this conversion. यहाँ पे आप देख सकते हैं 10 ml में इतना है, तो 100 ml में कितना होगा. So it's just cross multiplication and you will get your answer. Whether it is asked in 10 ml, 100 ml, 1000 ml, whatever is asked. अगर एक बार आपको 10 ml का पता चल जाए तो फिर आप फाइंड कर सकते हैं based on your question paper. So this is it about the journal, how you are supposed to write or note it down in the journal. We will move on to the video to see how this practical is performed. Anurga, could we go to the video? All right. Anyone? Any problem so far?
No, ma'am.
Oh, you are so good students. Okay, we'll continue.
Ma'am, Hello, ma'am.
हाँ हाँ, yes, yes. Who is having, who is this?
हेलो।
हेलो, हाँ, कौन है?
हाँ,
श्यामल, यस
श्याम।
श्यामल।
हमने HNO3 डाल के हीट क्यों किया?
हाँ हाँ, बताती हूँ। देखो, इसमें दोनों है, FE भी है, CR भी है, और इस पर्टिकुलर केस में दोनों +3 स्टेट में है। तो वो ऑक्सीडेशन स्टेट मेंटेन रखने के लिए हमने HNO3 ऐड किया है, कि अगर ऑक्सीडेशन स्टेट चेंज हो जाता है तो ये जो प्रोसेस हमने जो प्रोसेस यहाँ पे अडॉप्ट किया है वो सक्सेसफुली नहीं जाएगा। तो टू मेंटेन दैट ऑक्सीडेशन स्टेट वी हैव एडेड नाइट्रिक एसिड। इज दैट क्लियर, श्यामल?
Yes.
Okay. Anuga, I think we can continue with the video.
Welcome to Inorganic Chemistry Practical class. The title of the experiment is Determination of Chromium 3 and Iron 3 in a mixture by kinetic masking method. This video is brought to you by Dr. Harshendra K. and Dr. Asma, Department of PG Studies in Chemistry, Government Science College, Hassan. Kinetic masking is a special case in which a metal ion does not effectively enter into the complexation reaction because of its kinetic inertness. Thus, the slow reaction of chromium 3 with EDTA makes it possible to titrate other metal ions which react rapidly, such as iron 3, without interference from chromium 3. So, which is illustrated by the determination of iron 3 and chromium 3 in a mixture by kinetic masking method. Reagents required for this experiment are 0.01 molar lead nitrate solution, 0.01 molar zinc sulfate solution, 0.01 molar EDTA solution, hexamine, buffer solution of pH 10, xylenol orange indicator, and eriachrome black tea indicator. This experiment consists of three steps. Step 1 is standardization of EDTA solution. Step 2 is estimation of iron. Step 3 is estimation of chromium. For the standardization of EDTA solution, take the EDTA solution in the burette and pipette out 10 ml of the zinc sulfate solution in a conical flask. To that, add 3 ml of buffer solution of pH 10 and eriachrome black tea indicator. Shake the solution and titrate it against the EDTA solution till the color changes from wine red to blue. Note down the burette reading and repeat the experiment until you get the concordant values. From burette readings, molarity of EDTA was calculated by substituting molarity of zinc sulfate, volume of zinc sulfate, and volume of EDTA. For the estimation of iron, take the standard lead nitrate solution in the burette and pipette out 10 ml of the metal mixture in a conical flask. Place it on a magnetic stirrer. Dilute this solution with 20 ml of water and to this add 20 ml of EDTA solution. Add hexamine to maintain the pH of the solution between 5 to 6. Add few drops of xylenol orange indicator and titrate this solution against standard lead nitrate solution till the color changes from orange to violet red. Note down the burette reading and repeat the experiment till you get the concordant values. Do not discard this solution as we'll be using the same solution for the next step. From burette readings, volume of EDTA was calculated by multiplying molarity of lead nitrate with volume of lead nitrate and dividing it by molarity of EDTA. The volume of EDTA consumed is equal to 20 minus 9.19, which is the volume of EDTA calculated, will give the value of 10.81 ml. Molarity of iron in the mixture is calculated by multiplying the molarity of EDTA with volume of EDTA and dividing the obtained value with volume of metal mixture. Similarly, amount of iron in liter of the mixture solution is calculated by multiplying the molarity of iron with molecular weight of iron. To the previously titrated solution, 20 ml of EDTA solution was added and few drops of 1 molar nitric acid was added to maintain the pH between 1 to 2. The solution was boiled for 15 minutes until it is reduced to half. After boiling, it was cooled and diluted to 100 ml with distilled water, and to this hexamine was added to maintain the pH between 5 to 6. Few drops of xylene orange indicator was added and the resulting solution was titrated against standard lead nitrate taken in the burette till the color changes from orange to violet. The burette readings were noted down and the experiment was repeated to get the concordant values. From the burette readings, volume of EDTA was calculated by multiplying molarity of lead nitrate with volume of lead nitrate and dividing it with molarity of EDTA. Further, volume of the EDTA consumed is equal to 20 minus 10.6, which is the calculated volume of EDTA, which gives the value of 9.4 ml. Molarity of chromium in the mixture was calculated by multiplying molarity of EDTA with volume of EDTA and dividing the value with volume of metal mixture. The amount of chromium in liter of the mixture solution was calculated by multiplying the molarity of chromium with molecular weight of chromium.
Good.
Archana, you may continue.
Yeah, okay. So, all right. So, yes, Nikhil, you want to ask something?
Yes, ma'am. According to you, say in color change is yellow to red, but
Ah,
in videos we see that color change from orange to blue. Then which one is right, and which one we
on
say in examination?
orange to blue it was.
ऑरेंज टू ब्लू अभी हमने जो लास्ट प्रैक्टिकल देखा उसमें कलर चेंज हमें ऑरेंज टू ब्लू
हाँ हाँ
दिखाई
हाँ,
दी.
देखो
देन
इसमें
विच वन इज राइट?
इस वीडियो में आई थिंक जो रिएजेंट्स है वो भी थोड़े चेंज हुए हैं.
राइट, बिकॉज
Yes,
हम
Archana.
जब एग्जाम में जाते हैं तो वाइवा में हम जब कलर चेंजेस बोलते हैं तब हमें ऐसा मुझे ही पूछा गया था इस बार मैंने कल कि यू आर श्योर दैट दिस कलर इज कंफर्म कि अलग कलर आता है भी है. जैसे कि हमने वो सल्फाइड इन वाटर था तो उसमें उसमें नहीं, ब्रिक रेड आया था हमारा वो AgNO3 वाले में, नाइट्रेट में। तो उन्होंने मुझे तब पूछा कि ये श्योर है तुम, ब्रिक रेड ही आता है, दूसरा कलर आता है, ऐसा बोला था। बट वो मुझे अभी तक फाइंड आउट नहीं हुआ कि वो कौन सा कलर होता है दूसरा, क्योंकि जर्नल में तो हमें ब्रिक रेड लिखा हुआ था, तो हमने वही बताया, तब इश्यू क्रिएट होता है। तो श्योर कर दो ना मैम कौन सा आएगा।
देखो, उस केस में तो जैसे हम प्रैक्टिकल परफॉर्म करते हैं, ब्रिक रेड आता है, वाइट कलर के प्रेसिपिटेट्स भी आते हैं एडिशनली, लेकिन ब्रिक रेड जो होता है सिल्वर के साथ कॉम्प्लेक्स फॉर्म करके, वो होता ही है ब्रिक रेड। I'll just continue. Please wait. Anarva, you were saying something?
हाँ, यस, आई वाज सेइंग दैट कि आप लोग प्लीज़ अपने जर्नल को फॉलो करना। हम जो आपको बता रहे हैं वो जस्ट आपको आइडिया है कि कलर चेंज क्या है, कैसे परफॉर्म करते हैं, हम आपको वो दिखाने के लिए वीडियोस दिखा रहे हैं। और जो भी प्रोसीजर है जो हम फॉलो करें, जो ऑप्टिमाइज्ड पैरामीटर के साथ हमने जो परफॉर्म किया है, वो पूरा का पूरा आपके जर्नल में प्रॉपरली हमने बताया है। तो प्लीज़ फॉर प्रोसीजर फॉलो आवर जर्नल। अदरवाइज जो वीडियोस दिखा रहे हैं वो वीडियोस आपको समझ में आए कि कलर चेंज एग्जैक्टली क्या होता है। जैसे कि हमने बोला कि ईबीटी का कलर चेंज होता है वाइन रेड टू ब्लू, आपको समझ में ही नहीं आया कि ब्लू कौन सा ब्लू की बात कर रहे हैं, तो वो समझाने के लिए वी वर यूजिंग दीज वीडियोस। समझ में आया? सो प्लीज फॉलो आवर जर्नल। अभी जो आपका FECR वाला प्रैक्टिकल है उसमें वी हैव सीन दैट वीडियोस में दे हैव यूज्ड डिफरेंट रिएजेंट्स, बट इन आवर केस वी हैव यूज्ड डिफरेंट रिएजेंट्स। सो जस्ट टू मेक श्योर कि कैसा कलर चेंज होता है, कैसे प्रैक्टिकल परफॉर्म करते हैं, वॉल्यूमेट्रिक फ्लास्क को कैसे मेंटेन करते हैं, कैसे हमें मार्क तक हमें लेके जाना होता है, ये सारी चीज़ें बताने के लिए वी आर यूजिंग वीडियोस बिकॉज वी डोंट हैव एनी अदर ऑप्शन। सो प्लीज़ फॉलो आवर जर्नल। जो भी है हमारा जर्नल ही, उसमें सारे के सारे डिटेल सब कुछ प्रॉपरली बताया गया है। अर्चना, यू मे कंटिन्यू।
Yeah. I'll just add to it. Nikhil, you must have observed that when I was explaining this journal से पहले I showed you one printed note, right? You saw that?
यस मैम।
हाँ। अब क्या है, जब हम ये प्रैक्टिकल, पर्टिकुलरली ये वाला काइनेटिक मास्किंग, इनफैक्ट काफ़ी दूसरे प्रैक्टिकल्स में भी ऐसा होता है कि थियोरेटिकली जो देते हैं, जब हम प्रैक्टिकली परफॉर्म करने जाते हैं तो एग्जैक्टली वैसा कभी कभी नहीं भी दिखता है। तो दिस वन आई टोल्ड यू कि प्रीवियसली जो जर्नल है उसको चेंज किया, जर्नल में जो प्रोसीजर है वो आपको फॉलो नहीं करना है। ये हमने लैब में रिपीटेडली परफॉर्म करके, ये जो भी आप प्रिंटेड वर्जन देख रहे हो, ये हमने लैब में ऑप्टिमाइज किया हुआ है काफ़ी बार परफॉर्म करके, कितना करना है, कैसे करना है। हीटिंग, मैंने हीटिंग में आपको बताया, आपने वीडियो में देखा होगा कि शायद उन्होंने ऐसा बोला कि दे रिड्यूस्ड द वॉल्यूम टू हाफ, उसमें ऐसा था। Under the conditions we have optimized in the lab, we generally do not follow that. We wait until the solution starts heating, it becomes warm, and when bubbles start coming, at that point we have to take out the sample. तो आपको जो हम ये दिखा रहे हैं ना, ये जो प्रिंटेड नोट्स अभी आप देख रहे हैं स्क्रीन पे, इसी को ही फॉलो करना है। दिस वी हैव ऑप्टिमाइज्ड एंड केप्ट, एंड इन योर प्रैक्टिकल वी गेट इट लाइक दिस, सो डू नॉट वरी अबाउट दैट, यू फॉलो दिस वन थिंग।
ओके मैम, थैंक यू मैम। मैम ये वाली जो स्लाइड है वो हमें शेयर कर देना ना प्लीज,
हाँ,
फॉर ए प्रिंट।
PDF है ना, FECR वाला, ये बिल्कुल शेयर करेंगे, वी विल शेयर इट।
थैंक यू मैम।
All right. So this was about the iron chromium practical, and yeah. So here we are done with 3 practicals. Now we must have seen that these 3 go almost on the same pattern. 2 are very much same. The third one also. This is complex or metric titrations we were following so far. Now see, you must be knowing details about EDTA. अब 3 practicals complex related है, मतलब you are bound to know the history, geography, civics of EDTA. आपको पता होना चाहिए how the structure looks, what are the functional groups present in it, what kind of ligand it is, then general basic things about EDTA you should know. You should know about, जैसे कि मैंने बताया एक term, metallochromic indicator. So examples of metallochromic indicator आपने यहाँ पे देखा. You also go out and search which are the other metallochromic indicators that are present, that are available. There, yes, we mentioned about PS10 buffer, and PS10 buffer is not new to you. So, can anyone, last time it was there, so can anyone tell me how this PS10 buffer is made? Nobody? How is the PS10 buffer solution made?
Ammonium chloride and ammonia, NH4OH plus NH4Cl.
Google किया?
Sure. No मैम, इट्स वी आर डूड। हाँ गूगल तो किया पर अभी नहीं किया हमने। फर्स्ट सेम में जब आया था पीएच बफर तब गूगल करके इसको फाइंड आउट किया था।
Ammonium chloride and ammonium acetate, right? In ammonia, liquid ammonia, and the sufficient amount of water. It is given in your, when we share the journal, you will find the exact values. अगर 1 लीटर बनाना है तो कितना लेके करना है. So this thing also be aware of how to prepare this PS10 buffer. Other than this, I think it's fine with these 3 practicals, and it is hopefully it is clear to you. So, is there any other thing related to these 3 practicals? Finally,
हेलो मैम।
yes, Shaman.
जैसे हमने कैल्शियम और जिंक में जिंक का फाइंड किया,
हाँ.
वैसे हमको कैल्शियम का फाइंड करना है टाइट्रेशन करके, तो कौन सा दूसरा सॉल्यूशन यूज कर सकते हैं?
मतलब तुम्हें सेपरेट कैल्शियम को सेपरेटली फाइंड करना है, ऐसा?
टाइट्रेशन करके।
यानी एक मिक्सचर में से करना है या इंडिविजुअल कैल्शियम का करना है?
तो हमने वो कैलकुलेशन करके बाद में हमने कैल्शियम का फाइंड किया।
हाँ.
वैसे हमने जिंक का वो प्रैक्टिकल करके किया ना, कि जिंक का प्रैक्टिकल किया और कैल्शियम और जिंक में से दोनों में से बात करके कैल्शियम का फाइंड किया। ऐसे ही हमें कैल्शियम का करना है और जिंक का फाइंड कैलकुलेशन करके करना है। तो कैल्शियम का कैसे टाइट्रेशन करेंगे, मींस कौन सा
देखो,
सॉल्यूशन यूज?
अब इसमें ये एक मैटर है कि तुम्हारा जो कैल्शियम है उसके साथ दूसरा कौन सा मेटल प्रेजेंट है, ये जानना ज़रूरी है। अब तुमने ये देखा होगा कि 10 pH पे कैल्शियम बाइंड हो जाता है EDTA के साथ, लेकिन साथ ही साथ जिंक भी बाइंड हो जाता है। लेकिन अगर तुम कुछ ऐसा निकालते हो कि 10 pH पे तुम जिंक को किसी और के साथ बाइंड करके रखो या मास्क करके रखो, तो फिर एक्सक्लूसिवली कैल्शियम बाइंड हो जाएगा। अब इसमें काफ़ी सारे मेथड्स अवेलेबल है। pH अगर मेंटेन करके तुम करते हो तो काफ़ी सारे मेथड्स अवेलेबल है, लेकिन तुम्हें ये देखना होगा कि साथ में कौन सा मेटल है। बेस्ड ऑन द सेकेंड मेटल दैट इज प्रेजेंट, जो भी मेटल प्रेजेंट है उसको मास्क करके रखना ज़रूरी है। फिर तुम इंडिविजुअली कैल्शियम को 10 pH पे कर सकते हो, बाइंड हो जाता है।
ओके, थैंक यू।
Archana, I just wanted to add one thing.
Yes.
कि कॉम्प्लेक्सोमेट्रिक टाइट्रेशन में यू हैव टू नो व्हाट इज किलेटिंग एजेंट, कोऑर्डिनेशन नंबर, ये सारी चीज़ें भी पता होना चाहिए। That's it.
Yeah, exactly. So from Viva point of view, that becomes this EDTA is a chelating agent. You all must be knowing it is a chelating agent, right? So when I told you, you need to know stuffs about EDTA. So you will have to work out. Viva is totally different from your practical. You need to know the background of the things that you are using, the principle of the practical that you are performing, the mechanism. So you need to know. In fact, I think you have studied in your STEM core of your BSc about EDTA, how it makes complex and all. So you just need to recall those things, find out about more about the chelating part, the chelating as a chelating agent, how it works. And I think you should be fine. But you need to work on this particular thing. If this is done, I think we can wind up this particular lab session. Before that, I want to ask you, are you people free any other day Like I know you will be given, um, you will be allotted specific day for specific branches. So, like on Saturday or something like that, are you people available for practical, analytical practice? जैसे कि आपके टाइम टेबल में सैटरडे you are having, I think, only one lecture or something. Okay, before that, we showed you the video of calcium and zinc. Do you want to see of magnesium and lead? देखना है आप? Or would you prefer to get the link? Do you want to see it right now? People, do you want to see the videos of magnesium and lead now? Or would you like to have the link?
मैम ये दोनों तो सेम ही, कलर चेंज और जो हमें देखना चाहिए वो सब तो कॉमन ही है, तो इसमें कुछ ज़्यादा डिफरेंस नहीं होगा. तो इफ यू आर प्रोवाइडिंग लिंक, देन इफ जिनको देखना है वो इधर से देख लेंगे.
Fine. Then we'll do like that. We'll share the link and you can watch as needed. So I was talking about your. Are you people available on Saturday? You're having only one lecture, I guess.
Saturday, the morning session is free, Archana.
Morning.
Yeah, it is extra theory or lecture and assignment seminar.
मैम वी आर नॉट श्योर दैट वी आर फ्री ऑन सैटरडे, बिकॉज कभी भी कोई भी सर हमें ऐसे जिसको एक्स्ट्रा लेक्चर्स चाहिए वो तब सेट कर सकते हैं. सो हम अभी से नहीं बता सकते कि हम तब फ्री है कि नहीं. अदरवाइज हमारा एक ही लेक्चर होता है और 2 PM को होता है बस.
पूरा
वही
सर है ना?
यस, वोरा सर.
हाँ, तो आप फ्राइडे को हमें बता सकते हो ना कि आप लोग फ्री हो या नहीं फ्राइडे को.
यस मैम, फ्राइडे को तो हम बता सकते हैं कि हम किस तरह से सेट हो सकते हैं.
हाँ ठीक है, तो फ्राइडे बता देना, उस हिसाब से हम सेट कर लेंगे. व्हाट्स से अर्चना?
That's fine. कौन बताएगा?
ये बंदा कौन बोल रहा था वही बता देगा.
निखिल पटेल बता दोगे मुझे? फ्राइडे
मैं भी बता दूंगा.
बता देना मुझे फ्राइडे. हाँ, हमारा ये सेट स्लॉट ऑक्यूपाई होता है कि नहीं. Based on that, we will set the practicals and if there's nothing else, we can take your practicals on Saturday also. Okay? You inform, then I'll tell you. Based on that, I'll let you know, Nikhil, what is to be done to inform it to your class. Is that fine? अरे निखिल, हाँ या ना तो बोलो.
मैम आपका वॉइस क्लियर ही नहीं आ रहा, मुझे ठीक तरह से सुना ही नहीं दिया आप क्या बोल रहे हो.
हाँ, मैं ये बोल रही हूँ कि you inform me on Friday क्या status है. Based on that, we will tell you whether we have lab on Saturday or not, and then you just pass on the message to your classmates.
ओके मैम, श्योर.
है ना? हाँ, ठीक है. Now anything else is remaining, Anarga?
Before we leave, just let us take an attendance.
Yeah. Let me take the attendance. People don't leave.
मैम क्या आप ये रिकॉर्डिंग जो है वो हमारे MS टीम पे शेयर कर दोगे?
रिकॉर्डिंग का तो हम आपको नहीं बता सकते.
ओके मैम.
अच्छा,
हाँ, अभी फिलहाल तो अभी देखना पड़ेगा कि हम डायरेक्टली कर सकते हैं नहीं. We'll ask and then
बट आप लोगों को वीडियोस के लिंक वगैरह सब कुछ मिल जाएगा. डोंट वरी अबाउट दैट.
journals and everything you will be provided. सब कुछ अपलोड होता है. In case anything misses out या रह जाता है, just put in a reminder on this MS Teams. We will do it. In case something is left out.
ओके मैम।
देखो हम ऐसा भी कर सकते हैं, एक सेशन ऐसा भी कर सकते हैं अर्चना मेरी बात नहीं हुई है, बस वी आर टॉकिंग ऑन दिस प्लेटफॉर्म कि इन केस आप लोगों का प्रैक्टिकल एग्जाम आ रहा है, सारे प्रैक्टिकल्स हो जाते हैं, तो विल गिव यू अ 1 वीक ब्रेक, फिर आप लोग सब एक बार सब सारे प्रैक्टिकल्स यू गो थ्रू, इफ यू फाइंड एनी यू गो थ्रू द वीडियोज, यू गो थ्रू द जर्नल, इफ यू फाइंड एनी query or any difficulty in any of the practical, or कहीं पे भी कुछ भी doubt हो, you can come to us, like we can keep a session where everyone can interact, everyone can
Yes,
come up with their
definitely we
doubts.
can put that up. Yeah, we can have one session once all the practicals are done. We will give them some time, and they can go through all the practicals, and फिर आप
Exactly.
session रखेंगे.
जैसे निखिल को लास्ट टाइम जो प्रॉब्लम हुआ था कि क्वेश्चन जो पूछा गया था, he told us that still he was in doubt. So ऐसा सारी चीज़ें हम लोग we can overcome with a session once we finish our practicals. Is that fine with other students?
यस मैम।
Okay, great.
Yes, ma'am.
Fine. So अर्चना अटेंडेंस ले लिया तो अपन
हाँ, हाँ,
वाइंड अप कर सकते
attendance हो चुका है, हाँ. So Nikhil, Friday, just let me know. Then we'll decide. Or else, if it is not being set, we will meet next week. You all are free to leave.
ओके मैम।
Okay, thank you.
Students, you may leave now.
You can.
ये जो बाकी बचे उनको एंड मीट करे तो चले जाएंगे ना ये लोग.
मैं
क्या बोल रही?
remove कर
रिमूव एंड मीट में चला जाएगा, ऐसे तो रिकॉर्डिंग बंद कर देना.
हो जाता है.
हाँ, एंड मीट में हो जाएगा, रिकॉर्डिंग बंद कर देना.
Okay.
चल तो मैं निकलूँ ना.